Okay, this is going to be a video of the quizzes from the rationals unit. Okay, I want to make this so there's a lot of details in this chapter, and I want to make sure that you guys get all of them. Okay, so let's start. We're going to start with the one that says the quiz that says rational graphs. All right. So what you have to do on this is you got to go ahead and draw your asymptotes. So I'm going to draw. This is my vertical asymptote. And I'm going to draw this one as my horizontal asymptote, as long as they're reasonable, okay? So what that vertical one is, it's going to be x equals 3, okay? And then your horizontal is going to be y equals 2, all right? There's not going to be a hole, so that's going to be none. Okay, my domain is going to be all real numbers, except x can't equal 3, okay? All right, let me move this just a little bit. Okay? All right, my range here. Since the curves both go below, that's going to be y is less than 2. Normally we have all real numbers except where the horizontal asymptote is. However, since both curves are below, it's y is less than. The x-intercept, those cross at about 2 and 4. So x equals that. The y one crosses, let's say 1.9. Okay? Now, your answer to these end behaviors, whatever your horizontal asymptote is, so that's going to be 2 and 2. Okay? All right, so this one over here, what you're going to have to do on this bottom is I'm going to have to go to equal. So I'm going to go to menu and equal. I got to factor that. 1, 2, negative 3. Those factors are x minus 1, x plus 3. Okay, hopefully you can see that up there. Yep, you can. Okay, great. So what happens here is the x plus 3 gets crossed out. Now, the solution for that is my whole will be at negative 3. Remember, it's always opposite sign of the factor. So what I have left over is this. Okay? So what that means is my vertical asymptote. My vertical asymptote, I solve that denominator, which would be x equals 1. My horizontal, since I have a number over x, it will automatically be y is 0. Okay? So x equals 1, y equals 0. Okay? What I'm going to do is I got to plot, since I have a hole, I got to go here and plot that. So what I'm going to have, use your nice fraction button. The ABC button. Now, I don't have one of those on here, so mine's just going to be 1 divided by x minus 1. Okay? All right, and so I want to plug in that negative 3. That gives me negative 0.25. So negative 3, negative 0.25, which will be right there. That will be an open circle. Now I'm going to go to the graph. If I want to draw it, if you get that, hit select. Draw, you see the curves now. Okay, the curves are here and here. So I'm going to go through that point, down near the pink part there, down by both asymptotes. Okay? To find the x and y intercept, g solve root is none. So this would be none. Okay? G solve y intercept, y equals negative 1. Okay? Now, a little different on the domain. The domain is going to be all real numbers, except x can't be 1. And then also x can't be the whole, which is negative 3. So you have to account for that as well. The range will be all real numbers. Okay, but y can't be 0. Alright? And the difference between these, curves are below, curves are in the corners. That's how you know. Okay? Moving on to these problems here. Alright, so this one, there's not going to be a hole. I'm going to have none. Okay, this scenario, I solved the denominator to get the vertical, which would be x equals negative 1. Here I have x over x. So I would divide those numbers there, which would give me y equals 4. Okay, so I got x equals negative 1, y equals 4. Okay. And now I can use the calculator because I got no hole in the graph. Okay? So I got 4x, use your nice fraction button. 4x plus 3 divided by x plus 1. Draw. I can see the curves in the graph. Okay? So the curves are going to go here and here. Okay? To find those intercepts, g solve root x equals negative 0.75. All right? G solve y-intercept, y equals 3. All right? My domain will be all real numbers, except x can't be negative 1. And my range will be all real numbers, but y can't be 4. Once again, all real numbers, they're in the corners. This answer here is 4. Very important. Your x and y-intercept are not involved with the asymptotes or the domain and range. Only the asymptotes are involved in that stuff. Okay? So over here to this one, what I'm going to have to do is I'm going to have to factor both of those. So I'm going to go to menu and equa, polynomial degree 2, 3, 4, negative 4. Okay, so that's going to be as a factor of 3x minus 2. All right, and that's going to be negative 2. So 3x minus 2 and x plus 2. Okay, make sure you change the signs. All right, when I factor that other one, that's going to be x plus 2 and x plus 5. All right, now what happens here with this is the x plus 2 gets canceled out, so I'm going to have a hole at x equals negative 2. What I have left over is 3x minus 2 over x plus 5. Okay? What I have there, I would solve this part. That's going to be, the vertical is going to be x equals negative 5. Since I have an x and an x, I divide those numbers out front, which would give me y equals 3. Okay? So negative 5. Okay? 3. All right. Now I got to put this in the calculator. Got to put it in the table because I do have a hole here on this case. All right. So I graph what's left over. Okay. I got 3x minus 2 divided by x plus 5. Okay. My hole is at negative 2. So that's negative 2.6. Okay. So it's like in here. Now I'm going to go ahead and take a look at what this looks like. I'm going to go over to the graph and see what it looks like. All right, there's the curves. So in the corners, so this is going to go here and here. Okay, I can find the x and y intercept, g solve root, x equals 0.6. Okay, g solve y intercept, y is negative 0.4. Okay, all right, this horizontal asymptote will be 3, so that's 3 and 3. My domain will be all real numbers, but x can't be negative 5, x can't be negative 2. So you have to include the hole with that. Since they're in the corners, this will be all real numbers, but y can't be 3. Okay, so that's the graphed part of this. Okay, moving on to addition and subtraction. Okay, what you want to do on this, so let me make sure I got enough time on here. Fantastic. Okay, what you want to do is factor or GCF or opposite switch. Since this one looks backwards, I'm going to take out, that didn't work out too well. I'm going to take out a negative 1. That's going to turn that into x minus 5. Okay, this side is just going to stay x minus 5. There's nothing I can do here. So, this side, what's this side missing that this side has? Nothing. This side, though, is missing a negative 1. So I'm going to put negative 1 there, put negative 1 there. So what happens here is that's just going to be 12. I got to treat that 5 like a negative 5. So what I want to do is I'm going to do negative 5 times negative 1. That gives me positive 5. All over my common denominator. Well, 12 plus 5 would be 17. My common denominator is negative 1. With an x minus 5 right there. And that would be my answer. Okay? Very important you treat that negative 5, okay, like that. All right? This part here, I can't factor this, but I could take out a 3. So that if I took out a 3, that would be left with that. This I can factor. I want to go to equa 1, 0, negative 25. Okay, so that's going to be x minus 5, x plus 5. Okay, so what's this side missing that this side has? Missing an x minus 5. What's this side missing? Missing a 3. Now, when I graded your quizzes, the biggest thing, most people did that, but you didn't FOIL it right. 8x times x will be 8x squared. 8x times negative 5 will be negative 40x. If you leave off the variables, it's tough. 3 times 3x is 9x. All over your common denominator. So if you've got to make sure x times x is x squared. X times the number is x. Okay? All right? The only things that can combine are the negative 40 and the 9. Negative 40 plus 9, negative 31. So this is 8x squared minus 31x. Common denominator is 3. X plus 5, x minus 5. Okay? What I saw is a lot of people made this x or they left this off. You've got to make sure your variables are right. Okay? Third problem. Okay? You're going to have to do equal for that one. Okay? Polynomial, degree 2, 1, negative 5, negative 14. Okay? That's going to be x minus 7 and x plus 2. This one here, this side, I would take out a 4. So I'd be left with x plus 2. Now, what's this side missing that this side has? Just the 4. What's this side missing? This is missing an x minus 7. So, I got to multiply those. 4 times x is 4x. 4 times negative 5 is negative 20. Okay? Now, I got to treat that like a negative 5 when I multiply it. So negative 5 times x is negative 5x. Okay, and I saw this mistake a lot. If you go to negative 5 times negative 7, it's positive 35. All over my common denominator. So, 4x minus 5x is negative 1x. Negative 20 plus 35 is positive 15. All over my common denominator, which is 4. X minus 7, x plus 2. Okay? The big thing, once again, you got to watch that as a negative. Okay? Moving on to number 4 here. Okay? So what this problem really is 12 over x plus 2 divided by 1/4 plus x, or 6 over x plus 2. So what you have to deal with before the division is we got to get this into 1. So what I'm going to do, this side is missing an x plus 2. This side is missing a 4. Okay? So what I'm going to do is, that's going to be 1x plus 2. Positive 6 times 4 is 24. All over my common denominator. The only things that combine there are the 2 and the 24, which will give me 26. And the common denominator is 4 over x plus 2. Okay? Now, what I can do is I can drop this part down. Okay? So now I'm at this problem. So it's almost like I got to get this to this. Now what happens is you got to flip this second. What I saw a lot of people do was they flip this first one. Okay? So I got 4 over x plus 2, 1x plus 26. Okay, none of these reduce. This can't get any smaller. These are good. So what I can do is cross off this. What's left over? 12 times, see there's a multiplication. 12 times 4 is 48. And this is just going to be 1x plus 26. And nothing else can get any smaller there. Okay? But make sure you flip the second. Okay? Alright? Let's go to the other ones. Okay? Alright, so these are the multiplication and division. Okay? Alright? So what I'm going to do, all right, the bottom's easy to factor here. Okay, so I go to menu, I go to equal, polynomial, 1, 12, negative 28. Okay, I got x minus 2, x plus 14. X minus 2, x plus 14. Now, this top part, okay, you know what, let me move this down. So, whoa, I don't want to do that. Can I do that? No. I'll just move this just a little bit that way. That's fine. Okay, this part, x cubed minus 8. Okay, I'm going to go back into equal. I'm going to go degree 3, 1, 0, 0, negative 8. All right. Let me make sure mine's an a plus bi. All right, so you get one good one, two crazy ones. So that one would be x minus 2. Okay, now what you have to do is you have to use the box. X cubed, so this would have to be x squared. This is negative 2x squared. Now the x squareds need to cancel out here, so that's positive 2x squared, which makes this positive 2x, which makes this negative 4x. Once again, these have to cancel out. Positive 4x makes that positive 4, and negative 8. So the two factors here are x minus 2, x squared plus 2x plus 4. Okay? Now, I can cross some things off. You can cross off these. So what my expression is this over x plus 14. Now let's talk about restrictions. Let's make this easy. The restrictions are the solutions in the denominator. Okay? So, very simply, x minus 2, that restriction would be x equals 2. X plus 14, that is x equals negative 14. So those are the solutions. The domain is just the all real numbers, and you just put the restrictions. Okay? Don't overcomplicate that. So whatever's in the denominator, that's what you solve. Okay? All right? So now we're going on to this. Okay? This one you would go to equa. Now we're in degree 2 here. 1, 0, negative 16. I get x minus 4x plus 4. Okay, bottom is already x minus 7, x plus 4, times, okay, 1, 9, 20, x plus 4, x plus 5, okay, equal again to that, x minus 5, x plus 4. Okay, now, I'm allowed to cross off vertically, so I can cross off this and this. I can cross off vertically here, this and this. Diagonally, I'm allowed to cross off, but those aren't exact and those aren't exact. So what's left over? I got x minus 4, x plus 5, over x minus 7, x minus 5. So keep it that simple. The restrictions, okay, for 7, or x minus 7 would be x is 7. For x plus 4 would be x equals negative 4. X minus 5 would be x equals 5. And then this one's already covered by this. So my domain would be all real numbers, except x can't be 7, x can't be negative 4, x can't be 5. Okay? Moving on. All right? So what we got here? All right, we're going to go to equa. Okay? 1, 0, negative 4. Everybody should know how to factor that by now. Okay, x minus 2, x plus 2. Okay, this would factor 2, 1, negative 6. That's going to be 2x minus 3 and x plus 2. 2x minus 3, x plus 2. All right, this one's already done for me. Let's factor this one up here. 2, negative 13, 15. That's going to be x minus 5 and 2x minus 3. Okay, so vertically, can I cross everything off? Yep, I can go here and here. Vertically, nothing there. But diagonally, I can get rid of this x minus 2. Diagonally, I can get rid of this 2x minus 3. So the only thing left over up top, pretty simple. X minus 5. Done. Okay, don't outthink yourself on those. Okay, now, these, okay, x plus 6, that's easy. This I got to factor. X minus 7, x minus 4. Okay, now, the division turns into multiplication, and what you do is you flip. So this x squared minus 36, that result's going to go under there. So 1, 0, negative 36. Okay, so that's going to be x minus 6, x plus 6. All right? This is going to go up top. So I go 3, negative 10, negative 8. So that's going to be x minus 4, 3x plus 2. Okay? So remember, the big thing is you got to flip. You got to flip this one. Okay? So, nothing vertically, diagonally, the x plus 6's can go, diagonally those can go. So up top, what I got left over, 3x plus 2. On the bottom, I got x minus 7 and x minus 6. Okay? So those are the quiz reviews. Okay? Go back through that, practice that up. Make sure you can use equal. Okay? Make sure you can do some of those graph properties and you'll be fine.